Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we continue talking about multi-threading, and in particular the Java util concurrent package. In the previous video, I talked about a few of the data structures that are provided that work with concurrency and that help make common tasks easier for you. In this video, I actually want to go ahead and write kind of a more significant application, and I want to use the CyclicBarrier and demonstrate how we can do that. So what we'll do is we will pull up Eclipse, and let's go ahead and create a new Scala object. So I'm calling this parallel crystals, and there are in many ways, there are lots of problems you could choose to do in parallel. However, we need something that's short enough that I can demonstrate it in one, maybe two videos, and which is fairly easy to understand without too much background. So this example of crystal growth is a fairly simple one. The idea here is, imagine you have a 2D grid, and you have down at the bottom kind of a seed region where crystals, things can attach, and up at the top you're going to release little particles, and they randomly walk down through the entire space, and when they hit the bottom, when they hit something that has already formed a crystal, they stick there. Okay. And then you do this one after the other, after the other, after the other, and it actually forms a very interesting geometric pattern. And so that's what I want to write. Now, this is one of those, an example where, because these crystals are doing a random walk, it can take a while for them to actually hit the bottom of your drawing area. And so to help speed it up, I want to do things in parallel. Now, there are lots of ways that we could organize this in parallel. I want to use this as an example of a cyclic barrier. So one of the things that we're going to do, okay, so let's first, I guess we can go ahead and write some of our code for this. So we'll make a new panel. If I do a Control-Shift-O, it'll ask me which panel I want. I want the Java Swing panel, and actually I'm going to change this to Java Swing _. I'll go ahead and also put in, no, we'll let it figure out the other things for us. So I want this panel to be able to draw itself. Override def paint, and we pass it to graphics 2D. I also want to have an image. And this image, just for starters, I'll make it 300 by 300. Type int argb. Okay, and the drawing here will be as simple as g.draw image img00 null. I also want to set the preferred size to the size of the image. Oops. Sorry, wrong call. No set, just preferred size equals. So we'll set it so this panel is the size of whatever our image is, and every time that it repaints, it draws this image for whatever's inside of the image. We'll make a main frame for this to sit in. Contents equals panel. Center on screen. Okay, and then inside of here, frame dot open. So that will bring up the panel and it will draw whatever image. We can test this real quick. And there we go. We get a little panel with our frame. I have to admit, I wouldn't mind having this be set to all black in the background. Let's create a little scope here. Val G equals img dot create graphics g dot set paint color dot black g dot fill rect 0, 0, img dot get width img dot get height. Save, and what are it's taking that to be the I'm fine with doing this. Control Shift O brings in color. Okay, so we'll make an image, create the graphics, black it out, and then return that image. And now if we run this, good, I get a little window that's full of black. Might actually be nice to also do g dot set paint color dot white, draw a line of dot, now let's start at 0, go to an I dot get height -1, so I'm going to draw one line of white along the very bottom, okay, which might be hard to see, but that's fine. So that white is going to be the row of crystals at the bottom where things can stick to. And this is where things get interesting for the multi-threading. So after we've opened the frame, what I want to do here is run through, I don't know, right now this is a 300 by 300, so what do we have, 90,000 pixels in there. Maybe drop down 10,000 seed crystals inside of there. So for let's how do we call it, count in 1 to 10,000, and inside of each of these I want, or wait, no, it's we'll think about this, come back to it. I want to repeat something over and over again, and what I want to repeat is a dropping of a bunch of these crystals and have them do a random walk and go around. Here's the problem. If I have multiple threads and they are all going through and doing these individual crystals, I can run into some interesting race conditions where I have a one thread finds a place where its thing is supposed to stick, and because it is going to modify the image directly, it's going to call a set RGB, I can have two threads simultaneously doing get RGBs and set RGBs, and I can have some weird race conditions. Now for this particular application it might not cause a problem, but for educational purposes I definitely want to show you how to do it the right way so that we don't have those race conditions. So what I want to do inside of here is I want to new fixed thread pool of, let's say, I'll go with 6 threads for now. And what we're going to do inside of here is I want to make it so that each thread drops the points down and does it in a way that is thread safe, because they only read the image. They only look to see, have we hit something? Okay. And as long as they haven't hit something, they keep going. After they've all hit something, I want them to then so after one thread hits something, it should wait there. It shouldn't write, because if we write, then we're mixing reading and writing, and we run into problems with race conditions. So instead, I want to have it so that it, as soon as it finds the place to go, it just waits at that location, and then goes on to the next, and the next one goes until it finds and hits. Next one goes and finds it, hits. And this is where the cyclic barrier comes in. I don't want to actually place all of the points until all of them have gone through their cyclic barrier. Okay, so the way we're going to do this, actually let's change this. Val num threads equals 6. I don't want this to be a magic number that's inside of there. Points equals array dot fill of num threads and a tuple of util dot random dot next int of img dot get width comma 0. So we're going to start at the top here. If we look at points, it's an array of int tuples, and so each one of those int tuples represents a point. Okay. And so now I want to start up my a bunch of well, I guess technically 6 of these threads. I want to submit jobs, and I want them to keep going until the count has reached some level. So for I in 0 until num threads, I want to submit some tasks here. So inside of here, es dot submit a task, so a new callable, and sure, I don't really believe that we have to have it return anything, but Control-Shift-O, Java util concurrent, callable. Okay, so what's going to happen here is that each one of these threads is going to have a while. So while count is less than 10,000, I want to do the following. I want to have my point do a little random walk. So what we're going to do here, val new point equals pnts sub I. Actually, let's do this. Val x comma y. Each of these needs to be a random walk. So we're going to have another loop inside of here that keeps going until you run into something. Var flag equals true, while flag okay. I'm just going to fill those all with 0, 0s to start with. Var x equals util dot random dot next int of img dot get width -1 var y equals equals 0. Okay, so I'm going to, each thread is going to have its own two variables, x and y, and we're going to start off basically at the top of the window, some random point along the edge. And then while flag, we keep going. At the end, flag will be set to false when we run into something, and I'll come back and we can complete that. But let's go ahead and stub out what needs to happen. So after you've hit something, what we're going to do is we need to have a cyclic barrier. And let's go back and look at our API. Our cyclic barrier has a number of parties. We'll have to create that, and we have a call to await inside of there. Now the CB needs to be created up here. Okay, so we create a new cyclic barrier with the appropriate number of threads. We run through the loop, and each one of these is going to await. After they're done awaiting, if I is equal to 0, plot all points. Okay, and before we await, pnts sub I equals, let's do x, y. Okay, so inside of here we're going to have the moving of x, y around till they hit something in the image, till they hit a crystal that's already there. After they've moved and they hit something, then we store the tuple of their location inside of this array. Note that this doesn't have problems with the race condition because every thread has its own I, so you can't have a conflict. We will never have two threads trying to write to the same location, and then they await. Okay. After the last one hits the await, they will all wake back up and come back and start moving around. In some ways, let's do another await down here so that so we don't have problems with the threading. So for, as it's set right now with 6 threads, 5 of them will when they release from this await, we'll skip right over this and then they will await again. The other one in this brief interim is going to take all the points that were stored in here and plot them out into the image by setting an RGB. And then all of them jump back up into here. The other thing that I want to do here is increment num threads. Okay. I really don't need this to be callable. It doesn't have to return anything. Actually, and I don't believe that I can submit a runnable. Oh, I can't submit a runnable. Good. So that way I don't have to deal with the fact that I'm not actually having any return values here. So that's it for this video. We've spent long enough on this. We'll come back in the next video and we will work on finishing this up. We need to move crystals until they hit, and then we have the plotting of the points, and of course we'll have to debug this to make sure it works. So that's it for this video, and we'll come back on the next one and we will fill in the blanks.